Hey everyone, in this video we are going to continue talking about equations and inequalities. We are going to read the scenario and then come up with an equation or inequality. In the first part we dealt with linear equations and linear inequalities, and this is going to be the last linear inequality that we are going to deal with. And then after this we are going to start talking about exponentials and quadratics. So Josephine is baking cupcakes for a bake sale. Each batch of cupcakes requires her to use 3 eggs, and there are 15 cupcakes in each batch. So she has already baked one batch. She has already baked one batch, and in each one of these batches there are 15 cupcakes, right? That's what it says in here. 15 cupcakes in each batch, and she already has one batch, which is 15 cupcakes. If Josephine has 21 eggs left, what is the maximum total number of cupcakes that she can bring to the bake sale? So we are trying to figure out how many cupcakes in total, right? So she has 21 eggs left. How many cupcakes can she make out of this? Let's figure that one out. So we are trying to figure out the relationship between the eggs and cupcakes, right? So that brings me to this part of the question. So in each batch, she needs to use 3 eggs. Each batch has 15 cupcakes. So 3 eggs equals to 15 cupcakes. That's what it is. So if with 3 eggs you can make 15 cupcakes, how many eggs do we need? Let's say it is x for, or how many cupcakes can we make using 1 egg? What's 1 egg mean? How many cupcakes can we make using 1 egg? Okay, that's what we are trying to figure out. Because we have 21 eggs left, if I know how many cupcakes I can make with 1 of them, I can figure out 21 of them. So 3 eggs is 15. With 1 egg, it means like divided by 3, we would have 5 cupcakes. So using 1 egg, we can make 5 cupcakes. But if, let's just continue with 1 egg, I can make 5 cupcakes. How many cupcakes can I make if I have 21 eggs? This is the ratio that I need to set up. So if I do cross multiplication, 1 times x is just 1x, and then equal, this is called cross multiplication, 21 times 5. That's going to be 510 cupcakes. So with 21 eggs I can make 105 cupcakes. I'm trying to figure out the total number of cupcakes, but remember, I had already 1 batch that was made, that was ready to go, and then I can make 105 more. Add these together, 105 plus 15 is 120. So the maximum, like if she pushes everything, she can make 120 cupcakes. It could be less if she like breaks one of the eggs, or like if she messes it up, but this is the maximum number of cupcakes that she can make. I wouldn't look at that solution. That's kind of confusing. I don't like that solution. So if you want to, you can go ahead and inspect it and then see if you prefer using an inequality like that. Okay, the next example is a very common type of question. This is called exponential equations. We use this for population. We use this for usually bacteria population or people's population in a city or so. It's a very well-known kind of question for the state test as well. So the general form, when you see this word again, please understand that you are most likely going to utilize the exponential equation form, which is a equals, let me see, or you need the base number times I want to put it in there, times, and then let's just use, what letter do I want to use? Let's say C. This is what it looks like, any exponential form. In that case, this gives you the total. I don't want to confuse you because usually they use the lowercase a for this right here. Let's say this is x, uppercase. To be honest, neither one of them matters as long as you know which one is which. So this one would give you the total number. One side of the equation would give you the total number. So right before the parentheses, what you have is the initial number. And then this right here is the rate of increase or decrease. Usually it is a decimal, like 1.05, 1.029, 1.29, 1.75. Those are all increasing ratios because they are greater than 1. I've talked about this on some IXL assignments. If it is like 0.75, that indicates decreasing population because it's less than 1. Or 0.99, even that one is a decreasing because it is less than 1. 0.089, that's still decreasing because it is less than 1. And this right here tells you about the time. Could be the number of years, the number of weeks. It could be like those sort of things. Now let's read our question. A population of trees if you look at this, the setting is the same as my setting, but it looks a little bit more crowded, complicated. So that's why I told you that it doesn't matter what letters you use as long as you know which one of them represents what. So in here, this is the total, F0 is the initial, B is the rate of increase or decrease, and T is the time. Okay? They are still the same things, they just look a little more complicated. A population of trees is dying of a disease. Common sense. If they're dying, it should decrease, right? The number that we have in the parentheses, because this represents the rate, should be less than 1 because they are dying. So each year, 4/5 of the previous year's population remains. 4/5 is what I need in the parentheses. It's less than 1. It's what I have left with. So let's get started. In the parentheses, I don't know what my initial number is, but I'm losing 1/5 every year, so that I left with 4/5. If there are that many trees this year, that means that's my initial number. This right here is the initial. And this right here is the rate of decrease. How many trees will remain after 8 years? Let's put the initial number first. 2, 3, 4, 1, 6 times after 8 years. So if it is 8 years, there we go. Because it says each year, that means my unit is the number of years. I know that I'm dealing with the number of years, and it says how many trees there are going to be left after 8 years. So this one here, you cannot calculate this without a calculator, so I'll use my favorite calculator that is going to be available to you during the state test. So I will type the same thing. Can I just copy and paste this? 2, 3, 4, 1, 6. I don't want to. 2, 3, 4, 1, 6. And then I need a set of parentheses. Inside of this, I need 4/5. And then the year was 8. You can use your keyboard, or you can use the keyboard option on Desmos for this, right here on the lower left corner. That's our answer, 3928.55. So the answer is the same as what we found, but how many trees will remain? Rounded to the nearest whole number, because this is not a thing. You cannot have that many trees it needs to be a whole number. Round it to the closest, nearest whole number. That's going to be your answer. Again, usually we use this form when we deal with population of people, bacteria, trees. If it's a population question, most of the time it's going to be that way. Initial number times the rate to the power of the year, which will give you the total number of you left with. Okay, let's see this one. There are 100 grams of radioactive substance. Half of the radioactive substance decays each minute. So, like, what's the meaning of half? Half is 1 over 2, right? If you type this on Desmos, let me show you. If you don't know what its decimal value is, because we need the decimals, you can even use the fractions. That wouldn't change anything if you're going to use a calculator. So 1 over 2 is what half means, and then it means 0.5. As you type that fraction, it shows you its decimal value on Desmos. Oh, it also gives us what it is. Decays each minute. So this right here then is the number of minute. Using the inequality below, determine the number of minutes, or T, that the substance would have to decay before there are less than 6.25 grams of substance remaining. So I don't have that much space right now. I'm going to use this given table over here, okay? So let's say we have 100 grams initially, right? Let's see what happens after 1 minute. Once 1 minute is done, it's going to be the initial number times our rate, which is either 1 over 2 or 0.5, that doesn't matter. And then the T after 1 minute is going to be this. When you type this on Desmos, it will give you 50 grams. Let me take all of these to the side. Okay, this is after 1 minute. After 2 minutes, 100 is our initial number. It's going to lose half of it. What happens after 2 minutes? It's going to be 25. So since the setting is not that hard in here, because we are losing half of it every single time, after 3 minutes, we are going to have half of this left, and then you're going to have half of this left, and then you're going to have 3.12, no, it's not 125. Oh, it is 125, okay. So this is what happens after 2 minutes. It says before there are less than 6.25 grams of the substance, right? So now this is the problem part. We need to comprehend what we read, okay? So it says how many minutes should have passed before there are less than 6.25 grams of substance remaining. If we wait 4 minutes, there's going to be exactly 6.25 grams left, right? But what does this say? It says before there are less than 25 grams left. If it is exactly 4 minutes, if it is exactly 4 minutes, we have 6.25 grams left. So for that one to be less than that, it needs to be just a little more than 4 minutes. So let me see. I'm trying to find the right words for this. So if it said how many minutes should have passed for 6.25 grams left, the answer would be T equals 4. For this one here, we're looking for anything that is less than 6.25. So that area is right in between 4 and 5. It would pass that 4 minutes. So that's why our answer is going to be t is greater than 4 minutes. It could be 4 minutes and 1 second. But it needs to pass that number of minutes. This is the only part that you may end up with a problem if you have a similar question in your blue ribbon. Okay, here is an easy question, a very popular kind of question on the state test as well. So, Henry tosses a ball. This is a quadratic equation example, or it's an equation. Oh yeah, it shows it over there as well. So quadratics look like a curve, and you would have only one peak point. So this right here is a quadratic. There's only one peak point. This right here is a quadratic. 1 point, it's making a peak. So these are examples of quadratics. If you have more than one, that's cubic function right here. So let's talk about our example. Now that we know how quadratic functions look like, linear functions look like a straight line, quadratics are curve, and then there's going to be a 1 point either at the top or in the bottom. Henry tosses a ball into the air from the top of an 8-meter high hill. So 8 meter, the height of the hill is right here. That's where the ball is at. He's tossing it. It's raising 1 meter, where it makes 9 meters from the ground, and then it starts falling down. So this is where we are at 1 second. After 1 second, it's at its maximum height, which is 9 meters from the ground. And then it falls down. This is 2 seconds later. It's at 8 meter height, right? Right here it says 8 meter. Where he tossed the ball 1 meter high, it goes up to the 9 meter level and then goes down 1 second later from the maximum point. It gets back to the original position, and then second 3, it's right here, 5 meter higher than the ground. Second 4, it's at the ground level because this is the ground. Like this tells me how high it is from the ground. 0 is the ground level. 4 seconds later, it falls. Okay? 1 second later, it's at maximum. Second 2, it's at the original height where he tossed the ball. And then after 4 seconds, it's on the ground. After 3 seconds, it's at 5 meter height right here. Now let's read the question. Now that we kind of talked about the graph that we see, the path of the ball can be given by the equation, blah, blah, blah. We don't care what it is. But y is the height of the ball in meters, and x is the time since the ball was thrown. The graph of this equation is shown below. When does the ball hit the ground? When does the ball hit the ground? The ball hits the ground at this point. Look at the time stamp. It says 4 seconds. So after 4 seconds, the ball hits the ground. That would be the answer for this one. And I also discussed when it would be at maximum height, which is 1 second later. If it's 2 seconds later, it's at the original height, which was 8 meter. The same height that Henry tossed the ball. And then after 3 seconds, it's at 5 meter height. And then 4 seconds later, it's on the ground. Okay, scrolling down or moving on to the next page. This right here is one of this week's IXLs, directly proportional relationship, or direct variation. The distance sound travels varies directly as the time it travels. If sound travels 1,005 meters in 3 seconds, find the distance sound will travel in 5 seconds. So what we do, distance, find your constant. I use letter A, I think they use letter K. doesn't matter, times seconds. Plug in the given numbers as we did in IXL. So the distance given is 1005 equals the constant that we have that we don't know, and the 3 seconds, that's our y. Divide each side by 3. So A, my constant, would be 335. So what am I trying to find? Find the distance. Let's set up the equation again. The distance was equal to A times the number of seconds, right? But now I know what my A equals. It equals to 335. What else do I know? I know the number of seconds that I'm dealing with. So get rid of this. Put your second, which is 5. Multiply them together. It equals to 5, 7, 6, 1. So the distance would be 1,675 meters. Okay, it's the same setting. Instead of writing an equation, like after, here's what I did with IXL. We found this, A equals 335 for IXL, and then we plugged it back in here. We said that, okay, so distance equals 335 times the number of seconds. This was IXL. Now, for the study island, we have one more step, which is right here. Once we have our equation set up, we plug in the numbers given, and then we figure out whatever we are looking for. Okay, next question. The graph above shows the number of emails Sydney had received based on the time she had worked. By the way, this is called the linear equation. Okay? Direct variation, because as one increases, the other one increases as well. Based on the information in the graph, how many emails had Sydney received after 5 hours of work? Find the 5 hour on that axis. So this right here is the number of emails. This is time at work, number of hours. 5 is right in between 4 and 6, correct? So it would be, wait, what kind of divid? Okay, it's right in between them. So find one point. Okay, let's set it up then. Number of emails equals to either K or A. That's our constant that we are going to figure out, times the time, number of hours. You can put H, you can put T, you can put whatever you want to put. So now find one point on the line. Okay, so this point would work. For 10 emails, what was the name of the person? Sydney. Sydney needs to work. If Sydney works 2 hours, she gets 10 emails. 2 hours, 10 emails. Let's find our constant, okay? To get the A by itself, I gotta divide each side by 2. Because I have multiplication, division is the opposite. So A would be equal to 5. Now here, let me set up my equation. My original equation turned into the number of emails equals to 5 times the number of hours. Let's read our question again. How many emails had Sydney received after 5 hours of work? Now that I know she's working 5 hours, 5 times 5, that's the T, or the number of hours, is going to give me the number of emails that she's going to receive. 5 times 5 times 5 is 25. She would receive 25 emails in 5 hours. Let's see if there is another question. Page 3, nope, and page 4, Khan Academy videos. So if you think you need more help, I would first suggest watching these 2 videos on Study Island. All you have to do is click on the lesson name when you get on the blue ribbons page, Ohio Programs, High School Math, Algebra 1, and then click on the lesson tab. That's going to take you to this page where I solved all these questions. Get to page 3 and 4, you will see the videos. They might help you. Thanks for watching, and I will see you in another video.